Okay, hi everyone. So I'm going to try to do this lesson by video and hopefully this works out. I did it all once, found out none of the microphone works, so we're starting it all over again. So today's goal is to be able to write ratios, figure out how to use ratios to make proportions, and then solve those proportions and kind of understand what all of that means. So first thing I want you to do is go and watch this Math Snacks video. It's the next link right under this one in the Google Classroom. It's a little corny, well, maybe a lot corny, but it kind of really gives you a good context to what we're talking about when we're talking about ratios. So now that you've watched that video and come back to this, we're going to talk about kind of what ratios are. So as you saw in the video, ratios are comparisons of two things. So in the video, it was comparing how much she spoke to how much her date spoke. So I think in the first video, it was a ratio of 1 to 7. The second one, it was a ratio of, I think, 7 to 1, and then it was a ratio of 1 to 1. So a ratio is just comparing two quantities of things. So there are three ways to write ratios. You can write ratios as such as A to B or 7 to 1. You can write them with the colon, 7 to 1, or you can write them as a fraction, 7 to 1, and it's still a ratio. Obviously, either one of your parts really can't be 0. You can't divide by 0, so B can't be 0. But if you have a ratio to 0, you can't really find equivalent ratios, so that doesn't really work. A ratio of 3 to 4 is the same as 6 to 8. If you had the fraction 6 to 8, which is just a ratio of 6 parts out of 8 total parts, if you reduce that fraction by dividing the top and bottom by 2, then you're going to get 3 over 4. So just like the fractions, 6 over 8 and 3 over 4 are equivalent, so is the ratios of 6 over 8 and 3 over 4 are equivalent. One common example you see a lot as far as what ratios are used for would be a player's batting average. It's the ratio of the number of base hits to the number of at-bats, not including walks. So Minnesota Twins' Joe Mauer had the highest batting average in 2006. If he had 521 official at-bats and 181 hits, find his batting average. So the ratio would be 181 hits to 521 at-bats, or you might see it as 181 over 521. And actually, if you keep track of stats and look them up, they actually turn that ratio or that fraction into a decimal of 181 divided by 521, which gives a batting average of 347. So ratio is just a comparison of two numbers. You can compare more than two numbers. So extended proportions, extended ratios, are used to compare, rather extended ratios, are used to compare 3 or more things. So now we have A to B to C. So if we had 3 people talking in that bad dates video, it might be 7 to 1. So he spoke 7, she spoke 1, and the waiter spoke 2. So you can compare as many different things as you want. A lot of times you'll see 3 numbers, particularly in triangles, because triangles have 3 sides, they have 3 angles. So if we have ratios of angles that is 3 to 4 to 5, does it make sense that you would add 3 plus 4 plus 5 to be 180, the total number of angles, or the total sum of the angles in a triangle? That doesn't really work. But just like 3/4 is the same as 6/8, because they're equivalent fractions or equivalent ratios, and we were multiplying the top and the bottom by 2. Next, oh, no, that's a 4, sorry. Can't read my own handwriting. We can do the same thing here. Now, we don't know what we're multiplying by, so we just call it an x. 3x plus 4x plus 5x equals 180. So if we add all those x's together, we get 12x equals 180. And then if you divide by 12, you get x equals 15, if I remember right. Another place where we've seen a lot of ratios and 3-way ratios are Pythagorean triples. We talk about a 3, 4, 5 Pythagorean triple because 3 squared plus 4 squared square equals 5 square. And you could multiply each one of those numbers by 2. So you'd get a 6 to 8 to 10, which is also a Pythagorean triple because the relationship between the three sides is the same. So if you worked it out, 6 squared plus 8 squared would equal 10 squared. And you could multiply the 3, the 4, and the 5 by any number you wanted as long as it was the same number. That's what we're doing when we put this x here. The 3, 4, 5 ratio we were given is multiplied by some x, and we can solve for that x. If we want the measures of the angles, then of course we would have to do 3 times 15, which is 45. 4 times 15, which is 60. And 5 times 15, which is 75. And if you add all those together, you get 180 degrees. So the three angles are 45, 60, and 75. So you don't have to just do angles to do ratios. You can also do side lengths. So in this case, we have a ratio of sides that's 2 to 2 to 3. So that indicates that it's an isosceles trapezoid because we have two sides that are the same, and we know that it's the perimeter. So we can't add to 180 because we're not talking about angles anymore. We're talking about the ratio of the sides. So 2x plus 2x plus 3x equals 392, which gives us 7x equals 392. And if I figure that out, 392 divided by 7, x equals 56. And it's asking us for the length of the longest side. So that would be the one that's the 3. So 3 times 56 is what? 3 times 50 is 150. 3 times 6 is 18. So it's 168 inches. So that would be a way to use ratios for side lengths, not just angles. The perimeter of a rectangle, a little bit of a different application. Perimeter of a rectangle is 220 inches. The ratio of its length to its width is 7 to 3. So this is some factor multiple of 7, and this is some multiple of 3. That's really what we're saying when we say that that's the ratio. It could be 7 to 3. It could be 14 to 6. It could even be multiply both of them by a half, and that would make it 3.5 to 1.5. Right? So it's just anything that has that same ratio, that same equivalent fraction. Now, can I add 3x plus 7x to get to 220? No, because that's not the perimeter, right? The perimeter, I have to add all four sides, and because it's a rectangle, I know that opposite sides are congruent. So I would have 3x plus 3x plus 7x plus 7x equals 220. And then I could solve that piece. So 7 and 7 is 14, 14 and 6 is 20. So 220 divided by 20 is going to give me x is 11, which means this side is 77, this side is 33, and then the area, which is what it asks for, is 77 times 33, which is 2,541 inches squared. So a little bit, you had to do a little bit with that after you kind of got to the answer. Now, so those were all ratios. When you talk about two ratios that are equal, that's called a proportion. So just like if you look at this example right here, we have the ratio on the left of 6 over x equals 21 over 31.5. One way to solve a proportion is that you can cross multiply. This is the one time when you can cross multiply when you have fractions, two fractions that are equal to each other. So we get 6 times 31.5. That's pretty ugly. Try it again. 6 times 31.5 equals 21x. 31.5 times 6 is 189. And if we divide both sides by 21, we get x equals 9. Now, some of you might have looked at this and said, why can't I just multiply both sides by x to get the x out of the denominator? So then I would get, those x's would cancel, and I would get 6 equals, come on, right pen? Lost the pen, there we go. 6 equals 21x over 31.5. Multiply both sides by 31.5 to get rid of that 31.5 in the denominator. So then we would get 31.5 times 6. These 31.5s cancel, equals 21x. Same thing we got here. So cross multiplying, where you just multiply the two diagonals, two numbers or two expressions that are on diagonals, makes that a little bit easier to do. If we look at this, the next one over here in part B, it has more than one number on each part of the term. There are implied parentheses around all of these. The implied parentheses are really only necessary when you start talking about things that have a plus sign or a minus sign in here. So this is 3 plus x times 5 equals 2 times 4x. So you have to distribute your 5. 5 times 3 is 15. 5 times x is 5x. 2 times 4x is 8x. We subtract 5x from both sides. We get 15 equals 3x. And then we get x equals 5. So that's what we're talking about when we're talking about solving proportions. The other two are pretty much the same, so I don't think I necessarily need to work through all of them. When you start to write up proportions, I'm going to run out of time before I do this because I can only do it in 15-minute sections. So I'm going to close this one, and then there'll be one more that'll be really short to listen about the word problem.